Hello, this is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. Date today is 10/14/2024, and we are going to discuss what is Newton's first law of motion under physics. So, basically, the Newton's first law of motion states that if you have a body, if it's at rest right here, it will stay at rest. Okay. But if a body is in motion, it will stay in motion until and unless there is an external force which stops it. So that is basically Newton's first law of motion. Let's look a little bit more into that. So let's say this right here is a body right here, and the weight of this is 20 kilogram. Okay. So in order to move this body, right, you have to apply force this way. You have to apply force this way, or you gotta, pull this with a rope to move it, correct? So imagine that this right here, for example, is let's say this is a rough surface, rough wooden surface, okay? So if you push this with the same amount of force as you push the same body on a smooth surface, if you push it on smooth surface, it'll go further. But if you push this on a rough surface, it will stop faster than in comparison to when you push it on a smooth surface. Now, why is that? Obviously, it's friction. If you have a rough surface, there is more friction. If you have a smooth surface, there is less friction. Okay. And why does it even stop if it's a smooth surface, really smooth? Like let's say you go to a bowling alley, okay, and you toss a ball, it goes really smooth. But if you have, imagine if you have a long strip of a smooth surface, eventually the ball will stop. Maybe after, I don't know, maybe half a mile, it will stop. Why? Because there is air friction, something is stopping it. So you got to keep that in mind. All right. So now, what about in space? If you toss a ball up in space where virtually friction is zero, okay, that ball will basically keep on moving in space randomly until something hits it or something stops it. Why? Because in space, there is, like I said, there is virtually no friction. So that's basically, my friends, Newton's first law of motion. Um, Now, let's go ahead and look at some scenarios. So, if you have a ball right here, okay, and you push it with a constant speed, okay, so in other words, the speed doesn't change. If it's going 20 miles per hour, it will just keep on going, okay. So, what is the net force in that? The resultant force. Net force is going to be zero, okay. Now, this basically is constant speed 20 miles per hour. Okay. So now let's say another scenario. Let's say you have a ball right here. Initially, you apply force to the ball, okay, and it rolls at 5 meters or 5 miles per second. Then you push it a little bit more. Then it rolls at 6 meters or 6 miles per second. So in this particular case, what would be the net force? Net force will be there. Okay. Net force will be there. And I'll show you in my upcoming lessons how to calculate that. So also another thing, if you notice that the speed has changed. It was going 5 miles per second, 5 miles per second. Then it started going 6 miles per second. So there is acceleration also. So then the acceleration in this case is 1 meter per second square, right? Now, lastly, what I like to show you is that if you've got a ball right here, okay, and this ball is basically going like this, okay, kind of like in a circular form, right? Now, let me ask you this. Do we have net force in this? It's going at a constant velocity. Let's say constant velocity of 10 meters per second. Velocity is not changing. But do you think that net force is there? Yes, net force is there. Why is that? The reason net force is there because this thing is going in sort of like a circular motion. And if you think of this as a center, there is a force which is perpendicular to the motion, which is pulling it towards the center. So then this means that there is a net force which exists. Would you not agree with that? So then if you're going like this, if you let it go, okay, if this force right here, which is pulling towards the center, if you somehow take it away, then ball will go straight. So yes, in a circular motion, there is a net force also, and also acceleration. Acceleration is there. Okay. So that's all I wanted to go over today. Newton's first law of motion. In my upcoming lesson, we're going to go into physics, Newton's second law of motion, Newton's third law of motion, and also we'll solve lots of examples. So stick with me, and hopefully you guys can ace in your physics exams. If you like the contents, I would really appreciate it if you can share it. And also, if you like the contents, please go ahead and give me a like. Take care of yourself. Till next time.